Let's now see the first example about DeMorgan for conjunction. Okay, consider this fragment of code. Again, we got action 1 for if branch. We got action number 2 executed if we go to the else branch. So now here's a question. Right before we reveal it, you can also pause the video and think about. Okay, when is action number 2 executed? Over here, when is action number 2? Your answer should be a Boolean expression. All right. So there are actually two ways to solve this. Either we can apply the DeMorgan's law for conjunction, or I can solve that visually, right? Let me use DeMorgan first because that's something we just learned, and I also help you understand visually. Let's do both for your complete understanding. All right. So now let's think about this. In some way, I want to figure out for the else part over here. Under what circumstance am I going to execute action number 2? We did something very similar when we talk about the negation law previously. You can refer to it, very similar. So now I will only get to the else part over here if it is not the case the if branch over here condition actually evaluated true. So it is not the case that 0 less than or equal to I, and also I less than or equal to 10. It is not the case, right? And now according to DeMorgan, I'm saying that it is not the case that the conjunction is true. So that means either this is false or this is false, right? That's what we said. Okay, and you can refer to the DeMorgan law. So now it is not the case that 0 less than or equal to I, right? It is this part over here. Or it is not the case that this is true. So not the case I less than or equal to 10, right? Also equivalent to, so now we can apply what we learned before about the negation logical law, right? If I say not the case less than or equal to, not the case less than or equal to, right? So now it would be basically 0 larger than I, or less I larger than 10. All right. So guys, this will be the answer over here. So this will be the final answer to the question, when is action number 2 executed? Okay, so that'll be the answer. Let me reveal it over here. Just make sure I really got it right myself as well. Okay, very good. Of course, you can see, well, you might be wondering, are they really the same? Well, here, this is really the same, right? You're saying I less than 0 or 0 larger than I. They're the same, right? Hopefully you're convinced about that. That's how you do it, just by applying the DeMorgan law. You can do it alternatively using some visual over here. Let me put it here. Let me do it this way. You can see we got this part over here, 0 less than or equal to I. So what does that mean? So you can, well, I larger than or equal to 0. That's basically what it means. So I larger than or equal to 0 is basically this part over here. I larger than or equal to 0. Okay, and then another part over here is I less than or equal to 10. I less than or equal to 10 over here. All right. I less than or equal to 10. And then to really take conjunction over here, as we said in the week number 3 tutorial video for Java, I also mentioned that. So when you say conjunction, is really to take the intersection of the two ranges over here. So now we are really taking the intersection over here. Over here. So this is really the conjunction, right? About I less than or equal to 10 and also I larger than or equal to 0. All right, so far so good. And now we talk about the else part. So now for the else part, let me see. Let me use a pink over here. For the else part over here is really saying it is not the case. So that means outside the intersection. So that means either this way. Okay, let me just try to make sure I don't touch. It's either this way over here, or it's this way over here. Right, the pink one, right? And what are they? Well, you can see over here, this part over here means it is not the case that I is larger than or equal to 0. That means I is less than 0. And this part means it is not the case that I is less than or equal to 10. So that means I is larger than 10, right? So this part over here, right? That's how you can also understand it visually. All right, so I show you both. You can see, well, I would say you might just get tired of drawing diagram. you know, if for every example you have to visualize in this way. But I would say for your very initial understanding, that would be okay to visualize it. But I think ultimately this is what a mathematician would do. You have to apply laws over here, and then just to manipulate the symbol. That's what a mathematician would do, and also what computer scientists would do. All right, example number 2. Somehow very similar. Okay, I'm not going to visualize again for you, but example number 2, there are also 2 ways to do it. Let me show you just the DeMorgan way, and then I'll show you another way that's actually easier to see. Okay, I'll show you both. So now, question here, when is action number 1 executed over here, and also when is action number 2 executed? All right, let me answer this question over here first. When is action number 2 executed? So that means I'm going to go to the else part over here, meaning that this part over here is going to be actually false, right? So that means not the case, I less than 0. Oh, let me do it again. Not the case, I less than 0, and also false, right? So this means it is not the case that this particular branch condition over here is false. That's why we go to the else, all right? So how do we use the DeMorgan law? So this will be equivalent to, okay, so it is not that these are both true. So that means either this is not the case, or this is not the case. All right, and then let's use the law for negation. And this part over here is going to be I larger than or equal to 0, or not false is going to be true. All right, equivalent to. So now we know that for disjunction, as long as one of the operands is actually true, the result is just going to be true. So we know that else is really true. And if else, well, let me just revalidate the answer over here. So this would just be true. Okay. And i.e. what I just described over here. And now if you think a little bit conversely, if else part is simply false, the if part should be simply just the opposite, the logical negation of true, which will be false, which means somehow this expression over here can just be simplified to just false. All right, hopefully you can see why, right? So now this is the second way I want to talk about, right? So now if this was a question asked by you, that you were asked over here, when is action number, I already finished the first way of illustrating. Let me show you the second way. If you were given the question, when is action number 2 executed, right? And now I will look at the if statement over here, and then I see that, well, since you're talking about a conjunction, I less than 0 and also false. You're talking about conjunction over here. However, one of the operands is already false. Remember, the only way to make conjunction true is when both operands are true. But now one of them is already false. So that means no question about it. This is already equivalent to just false. So I don't really need DeMorgan if I try the second way. It's like a special case. So I know that this this branching condition here is already false, meaning that the else part will just be the negation of false, which will be true. That can also give me this particular answer, right? You can try either way. Either you use DeMorgan, like what I did over here, or you can try to look at the branching condition over here. In this special case, since one of the operands is already false, you will know that this branching condition is false. So that means the else part is simply just true. You will get just this the same answer. All right. And then for this part here, it would just be false, right? All right, so that's a second example, right? So you can see example number 1, number 2 are kind of different. I try to show you different ways of solving it, right? Use whichever that works for you. All right, number 3, one more example about conjunction. All right, again, something similar. When is action 1 executed, and also when is action 2 executed, right? The same question. And I'm also going to visualize for you. Why don't we try visualization first this time, quickly? All right, so now what about the if condition over here? The if condition here, we say I less than 0, strictly less than 0, right? Strictly. So I strictly less than 0 does not include, and also I strictly larger than 10, strictly larger than 10 over here. So now, however, you can see we're trying to combine these two relational expression using conjunction. So now, is it possible to have a number that is it possible to have a line? Is it possible to have a number in the number line such that it's going to be in this region and this region at the same time? It's not possible, right? So that means, visually speaking, this part over here is simply equivalent to false. All right, already. And if this part is already false, that means the else part will just be true. So the answer will be action number 1 will just be false. And for action number 2, you will execute it when it's actually true. So the first way I'm trying to tell you how to solve it is by simply look at this condition over here and then visualize it. You can see it's simply not possible to find any I value to satisfy this simultaneously. Satisfy this and satisfy this. That's why this will be false. So that means action number 1 will never be executed. Right? I'm going to give you a little bit of conclusion in just a moment. Oh, that'll be approach number 1 to solve it. What about approach number 2? Approach number 2 would be for action number 2 over here, if we want to use DeMorgan, how do we do that? So that means the if range over here is not the case. All right. So not the case that I less than 0 and I larger than 10. Equivalent to this is not the case. This or this is not the case. This is not the case, or this is not the case. Equivalent to, for this one here, I larger than or equal to 0, or negating this, I less than or equal to 0. All right. So now, let's see this. How do we interpret this particular expression? That's also interesting to see. All right. Why don't we try this? I larger than or equal to 0 is like this. I larger than or equal to 0. And then we got I less than or equal to 0. I less than or equal to 0. Like this. And then we are saying that it's either this or this. So whenever we find any number in the number line, you can find 0, which is going to satisfy either one of them for sure. It's going to satisfy both. If you find any positive number, it's going to satisfy the pink constraint. If you find any negative number, it's going to satisfy the orange constraint. So that means this constraint over here will always be true. Any number will satisfy that. That's how you actually show it visually. All right, guys, I think really try to think about the different approaches I try to show to you. All right, let me give you some conclusion over here. If you look at that, if I ask you to really criticize this program, how would you criticize it? Because if you actually got this particular branch over here that's equivalent to false, that means you never ever will get a chance to really execute action 1. Equivalently, you will always execute action number 2. In that case, why would you put action number 1 over here in the first place, right? So that means if this is simply false, that means action number 1 never executed. And then action number 2 over here always executed. This is not good, because in that case, why don't you simply just get rid of this branch and then simply just put action number 2? There's no need to be selective. So this branching condition here is really doesn't sound right. So you shouldn't really put any branching condition that's equivalent to false. Of course, I simply put false over here just to give you some idea about if you somehow your branching condition is somehow equivalent to false, that means it's never executed. Then why did you put it in the first place? Similarly, this condition over here, as we said, is simply equivalent to also false. So that means action number 1 is also never executed. Okay, so this one over here is also never executed. One thing to say, in this example number 2 here, it's quite obvious to see why this would be false, because you just got false over here for conjunction. On the other hand, this one here, for example number 3, you will take a little bit of analysis in order to see that one is equivalent to false. Okay, it's never executed. Also, it's kind of useless, right? And then also action number 2 over here is actually always executed. All right, so that's about the 3 examples about DeMorgan for conjunction. All right, hopefully you're okay. And you can also look at the slides exactly the same information. I think I said even a little bit more about insights about this example using iPad. All right, so now let's move on to the next 3 examples about disjunction quickly. All right, so now for disjunction here, I'm just going to apply the DeMorgan law. If you want to visualize, feel free. Okay, I'm going to skip that part. You already know how to visualize it based on what I just did. Okay, when is action number 2 executed? So that means this branching condition here is going to be evaluated to false, right? And then we'll go into this part over here. So that means not the case I less than 0 or I larger than 10, which is equivalent to over here. So DeMorgan for logical disjunction, which means this must be false and also this must be false, right? In order for the disjunction to be not the case. So now not the case I less than 0 and also not the case I larger than 10, equivalent to, so now negating less than, so that'll be I larger than or equal to 0, and also negating larger than, so I less than or equal to 10. Okay, so now let's see exactly what this means. Well, actually, this simply just means, let's try to, just visualize the result, okay, too quickly. Over here, you can see this result over here, I larger than or equal to 0, and also I less than or equal to 10. This part using conjunction. So it's exactly this part over here, including 0 and 10. I larger than or equal to 0, and also less than or equal to 10. So this is the condition under which action number 2 is going to be executed. So this will be the condition for action number 2. On the other hand, the rest of the condition, either I is strictly larger than 10, or I is strictly less than 0 over here. You can see or, right? Either this range or this range over here. In that case, you will execute action number 1 over here. So this part over here will be action number 1, or this condition over here will be for action number 1. All right, let's now reveal the answer. That's exactly what I just said. All right, let's now move on to example number 2. Now for example number 2, again, this one over here, you can definitely apply DeMorgan. I'll leave that as an exercise for you, and I'll try the one way without the DeMorgan. So what about when is action number 2 executed, right? So now else part over here is going to be not the case, the branching condition for if, right? Not the case I less than 0 or true. And now apply DeMorgan. So I'll leave this as an exercise for you. Okay, exercise. Okay, what should that be? All right, let me just show you another way to do it. Another way to do it is, since now we are talking about disjunction, and then you can see one of them is already true, right? As long as one of the operands is actually true for disjunction, the whole thing is simply just going to be true, right? So now I less than 0 or true. Since one of them is already true, overall is simply just going to be true. Meaning that the else part will just be the negation of true, which will be false. So when is action number 2 executed, it should be false. So now when you actually finish the exercise over here for DeMorgan, eventually you should really get should be equivalent to false. But let's see if you will get the answer. Do this exercise, okay, for your own good. And then I think that's about it. All right. And then for action number 1, it is simply just true. All right, as I just explained. Let's now move on to the last example. But for this one here, you can see also the program does not seem to be right, because you can see this part over here is actually equivalent to true. So that means action number 1 is always executed. Meaning that action number 2 for the other logical negated branch never executed. So there's something wrong with this program. if you never want to execute action number 2, why did you bother to put it in the first place, right? Okay, let's move on to the final example. Okay, we have seen 5 examples so far, right? Let's see this one here. Will be a very similar way. I'm gonna justify visually for you, and then I want you to apply the DeMorgan yourself. All right. Let's say this part here. Let's say when is action number 2 executed, right? So when will we get to the else part? So that means this part over here is actually going to be false, not the case, right? So else part will be not the case, I less than 10 or I larger than or equal to 10. I'll just do one step together with you, just one step. So now for DeMorgan, for the disjunction, it would be this is not the case and this is not the case. Not the case, I less than 10 and not the case, I larger than or equal to 10. And should be equivalent to whatever, right? That'll be exercise for you. And this step over here is already demonstrating DeMorgan. All right, so now let me also try to justify also visually very quickly for you. So now we are saying this, I less than 10, I strictly less than 10 over here does not include 10. Let me just make sure I don't touch the point. I less than 10, I larger than or equal to 10, I larger than or equal to 10, right? So now these, I can move them a little bit over here, so you will see exactly what I mean over here. Okay, good. So now visually speaking, we're saying that any number is going to satisfy, going to be either here or here, because we're using disjunction. Should that be true or false? It should be true, because if I got any number, for example, 9 is going to be here, 10 is going to be here, and also 15 is going to be here, right? So all any number is going to satisfy either the green or the orange. So this part will just be equivalent to true, meaning that action number 1 will always be executed. Equivalently, so action number 2 will never be executed because the negation of true is going to be false, never executed. All right, so that means this result over here eventually you will get should be equivalent to false. Make sure you double check the answer for your exercise, right? So now if I reveal the answer over here, it's going to be true over here, and then it's going to be false over here. And then this will be the result from DeMorgan. All right, so that's about the final example. All right, guys, so far we talked about the DeMorgans for conjunction, disjunction, and we have done 6 different examples together with you. And also we did a truth table, right? You really want to review this and then make sure you understand it before you move on, right? So final topic for now, we want to talk about quickly about precedence and also associativity for the operators.